Okay, let's go over what you have done so far. So the first one here, negative 28 minus 37. That's going to turn into a negative 28 plus a negative 37. So negative 28, negative 37, that's going to be negative 65. Good. Number 2, negative 25 times a negative 8. Well, negative times a negative is positive. 25 times 8, 200. 32 minus a negative 19 becomes 32 plus 19, or 51. 56 divided by negative 7, well, is a negative, and 56 divided by 7 is 8. You are correct. Negative 86 minus negative 94 becomes negative 86 plus 94. So it's negative 86. Positive 94 is positive 8, or just 8. Negative 12 times 5. Well, negative times a positive. Negative 12 times 5. 60. Any questions? Any questions off the homework from last Thursday? Okay. You do have a quiz here. Problems 1 through 6 on the quiz. I say no calculator, but what I mean by that is you must show work. Whether you do that at the bottom of the page or off to the side or whatever, you can go back with the calculator and double check your calculations, but you will not get credit for those unless you show step by step what has to be done to do those calculations. So I will pass. Okay, so today we're going to take a look at problems that look like this. Now, some might look at a problem like this and say, hey, we read from left to right. I'm just going to do the problem from left to right. Now, don't write this down because this is going to be wrong. So 12 minus 3 is 9. 9 times 5 is 45, plus 7 is 52. And that makes perfect sense, only it's not the right answer. There are a lot of different ways that people could look at this problem and interpret it and go about solving it. But many of those different ways will give you different answers. And in math, we tend to like that if two people do the problem, we like to have them get the same answer. So for problems like this, we've defined something called the order of operations. Now, the order of operations only applies on a problem like this where there's no context to it, no story, no real life application. If there's a real application going on, usually the situation defines what has to happen first. You know, if you are going to, I don't know, combine two pieces of metal and then chop it into equal pieces, well, you know, you're going to add, then divide, whatever. So order of operations only applies when you have a generic problem like this, where there's no description telling you what's going on with the operations, what's really happening. Second, a lot of people mistakenly think that the order of operations is a list of steps, and it really isn't. What it really is levels of priority. And with the highest levels of priority have to happen first. Now, that doesn't mean you're going to go down 1, 2, 3, 4. What it means is you look at the highest level. If you don't find anything there, you go down to the next level. But you may have to jump back up to the higher level again later. And we'll show you what we mean in some of our examples coming up. The highest level of priority, first thing that would ever get done, is called enclosing symbols. Now, a lot of you have probably heard this first level being called just parentheses. And parentheses are one type of enclosing symbol. But there are several enclosing symbols that we'll encounter. Absolute value is an enclosing symbol. Square root's an enclosing symbol. We're going to run into a few of them. Second level of priority is exponents. And exponents include powers and roots. Third level priority is multiplication. Now, I've already said that multiplication and division are really the same operation. So, of course, that does include division. And the final level of priority, the lowest level of priority, level 4, is addition. And yes, because subtraction is part of addition, that goes there too. So back to our original problem here. Looking through, are there any enclosing symbols? No. Exponents? No. Multiplication and division? You bet, right here, 3 times 5. Now I get asked all the time, is that 3 times 5 or is that negative 3 times 5? And the answer is yes. It can be either. You could change it to 12, but if you're going to do negative 3 times 5, I'd change it to 12 plus a negative 3 times 5 plus 7. So now it's a negative 3 times 5, but it's a plus. So it's usually easier for me just to do it as a 3 times 5 and leave it as a subtraction. So 3 times 5 is 15. This is 12 minus 15 plus 7. Now all that's left is addition or subtraction. And when there is more than one item on the same level of priority, then we do, like reading a book, go left to right. So we're going to do the 12 minus 5 first is negative 3. Negative 3 plus 7 is 4. So the correct answer to that is 4. Way different than the 52 we had before. Well, let's look at something a little more difficult than that. Oh, come on. I guess we'll stop there. We're out of paper. Just a little bit more difficult. I mean, it looks like kind of a monster, but it really isn't that bad. So first level of priority is enclosing symbols. And on this one, we have parentheses. Now, there's several of them. Remember, we said if there's more than one item on the same level of priority, we go left to right. So left to right, this is the first parenthesis we run into. Now we have to find its other end to decide where it is we're going to focus. Is this one it? No, that one's facing the wrong way. How about this one? Nope, that one goes back here. This one's facing the wrong way. That one? Nope, that goes back here. So this is the other end of that parentheses. So what that means is we're going to narrow our focus inside that parentheses. We're going to say inside the green box. But now inside the green box, the order of operations still applies. We have more enclosing symbols. So again, we go left to right. This is the first one we encounter. So we're going to narrow our focus inside that parentheses. So inside the red box. Inside the red box, order of operations still applies. Any other enclosing symbols? No. Exponents. You bet. 2 to the third power, which is 8. So I take out the 2 to the third power and I replace it with 8. Nothing else changes. The biggest mistake I see students make on these, one of the biggest mistakes, is making mistakes copying down the problem. One of the reasons is they try not to copy down the whole problem. They'll try to just copy down part of it, and they'll try to do multiple steps at once so they don't have to write it down. Problem is when they try to do multiple steps at once, usually they're doing one step that's okay to do and another step that they should have really waited to do. What is the next thing that should happen here? Yep, we're still working inside that parentheses. 24 divided by 8, which is 3. And now that we're down to a single number inside those parentheses, I don't need the parentheses anymore. So I can get rid of that set of parentheses. They're gone. Now that parentheses is gone, so I'm back out to working in this green box, the bigger set of parentheses. In there, I got to go back up my levels of priority, back up to the top. Any other enclosing symbols? Yes, right here, another set of parentheses. So notice that these order of operations are not steps, they're levels of priority. We can go back up and down the levels, depending on what's there. So inside that parentheses, all we have to do is 5 minus 3, which is 2. Again, we're down to a single number in that parentheses. We no longer need the parentheses. We're going to take them out. So once again, we're back out to this larger set of parentheses, or green box again, if you will. In there, any other enclosing symbols? Say no. No. Any exponents? No. Multiplication or division? There's one here. 2 times 4, which is 8. Okay, so still inside that parentheses. No more multiplication or division, so we're down to addition and subtraction. So we're going to go left to right. 13 minus 3 is 10. Ten plus 2 is 12. Twelve minus 8 is 4. Now again, we're down to a single number inside that set of parentheses. We can get rid of the set of parentheses. But this time, when we get rid of the parentheses, there's something we have to do. Is you going to see what it is? We have to put in multiplication. When there's a number next to the parentheses with no symbol there, that's implied to be multiplication. I'm going to scroll up for a minute. You know, this one here had an operation on each side of it. Same here. This one had an operation on each side of it. If there's an operation on each side of it, we can remove the parentheses when we're done, and there's nothing to do. But here, there was not an operation between that number and the parentheses. So when we take out the parentheses, we do have to remember to put in that multiplication. So now down to this problem. Any more enclosing symbols? Nope. Exponents? Nope. Multiplication, division. A couple of them. 2 times 4 is 8. 3 times 5 is 15. Down to just addition and subtraction. 9 plus 8 is 17. Minus 15 is 2. All that for a 2, huh? Any questions? Okay. Next type of problem I want to look at is something like this. Let's do this. Come on. So, to do a problem like this, we have to figure out what is this symbol here? What's this line across here mean? Divide. It does mean divide. It's called a fraction bar. And part of what it means is divide. But it's also an enclosing symbol. It separates part of the problem from the rest. It is telling us we have to do everything on top here first. Then everything on bottom. Then divide. If you're punching in the calculator, your calculator, actually like this problem up here we just did, if you punch that in your calculator properly, it will do that whole thing for you. Calculator, your scientific calculator does order of operations quite well. This one here is very, very tricky to enter into your calculator. Some of your calculators have a math type mode where you can actually put in a fraction and do it like that. Otherwise, it is simplest if you get an answer for the top, an answer for the bottom, and then divide them out. So anyway, on top, if you put the parentheses in there correctly, it will work. Yeah. It's just most people struggle to figure out where to put the parentheses, or struggle to remember to put the parentheses in correctly. So here, what do I have to do first? 5 squared is 25. And then multiplication, 7 times 3 is 21. So 21 plus 25 is 46. Plus 2 is 48. So the top of this is 48. On bottom, what do we have to do first? Square root of 9. 3. Technically, it could be a -3, but we're only going to deal with the positive possibility here.
Square root is the opposite of square.
Yes. Yeah, square root is asking what number squared equals the number inside this symbol. 7 times 3? 21. Then as we move left to right, we find division on the 35 divided by 7, 5. And 21 minus 5 is 16. So the bottom 16. 48 divided by 16 is 3. Excuse me. Actually, that's what I wanted. So here, the square root is an enclosing symbol. We have to do everything inside there first. Yes. So we have to do the exponent. So 4 squared is 16. And then multiplication and division, left to right. 16 divided by 16, 1. And then 9 times 7 is 63. And then 1 plus 63 is 64. Now, just like with the parentheses, we're down to a single number inside our enclosing symbol, which means we can get rid of the square root symbol. The difference is with the parentheses, we just got rid of them. With the square root symbol, absolute value, some of our other enclosing symbols, in order to get rid of the enclosing symbol, we actually have to do an operation. And here's just like that. To take out that enclosing symbol, the square root, we have to do the square root of 64, which is 8. Also, just like the parentheses, we have the 3 in front of it. We have to put what in here? Multiplication. That is 3 times 8. So now we've got the 3 times 8, which is 24. 12 plus 24 is 36. Any questions? Yeah, they tend to define it a little bit differently. They go through these steps. And math isn't about steps. Math is about relationships. You know, you'll see me up and on the board here do some fairly long calculations, especially when we hit decimals and fractions. Do some fairly long calculations in my head. But it's because I don't memorize processes. I know the relationships. And once you know the relationships between numbers, there's patterns that develop. And once you start seeing those patterns, you start to do a calculation, you see the pattern very quickly, and the calculation is very simple. For example, give me a number between 20 and 50. 25. If you do 25 divided by 7, that's going to be 3.57142857143 approximately. Give me another number between 20 and 50. 33. 33 divided by 7 is going to be 4.714286 approximately. I can keep going, but we'll stop there. Like I said, it's about patterns. Once you start seeing the patterns, the calculations are really simple. Your calculator, by the way, will probably round this one off right about there.
Nope. It's 142 feet.
Stop right here.
Nope,
This one here.
No, 25 divided by 7. You got it right to the end, and then it rounded on the last three.
Oh, this should be 2. Yeah, this should technically, if I kept going, this would be 14286. Yeah. What's that?
28571. Almost. I'll give you that.
Oh, it kept going. 28571. It stopped here. Is what you're saying?
It repeated.
Oh, it just kept going.
Yeah.
Yeah. I just stopped there and rounded off. If you go to that digit and round it, I rounded correctly.
Yeah.
I could actually go for about 50 digits if you wanted me to there. Yeah.
All right. How about 41?
41 divided by 7. That's going to be 5.8571428571443 approximately. Okay.